Limiting reactant s'mores. So my recipe for a s'more is 1 Teddy Graham cracker, 1 chocolate bar, and 2 marshmallows. So your recipe might be a little bit different, but for this activity, we're just going to go ahead and stick with this recipe. Now, if we were part of a large s'more making company where we make and sell s'mores, we wouldn't buy individual graham crackers or chocolate bars or marshmallows. We would buy them by a gross. So a gross is a certain number of things. Kind of like how a mole is a certain number of things, a gross is just a certain number of things. Now, a gross of Teddy Graham crackers is going to weigh 9 pounds. A gross of chocolate bars weighs 36 pounds, and a gross of marshmallows weighs 3 pounds. So this is pounds per gross, which is kind of like grams per mole, which is molar mass. So if we have 100 graham crackers, how many chocolate bars and how many marshmallows would I need to use all of those graham crackers to make s'mores? So we know that if we start with 100 graham crackers, that the ratio of chocolate to graham cracker is 1:1. So this means that we would need 100 chocolate bars. If we start with 100 grams and we use the ratio of graham cracker to marshmallow, that is a 2:1 ratio. So we would need 200 marshmallows to use up all 100 graham crackers. So this is sort of like a mole ratio. It's the ratio of the different components that I need to make s'mores. So if we have 1,000 graham crackers, 800 chocolate bars, and 1,000 marshmallows, how many s'mores can we make? So if we start with 1,000 graham crackers and we use all of them, and assuming there's enough of the other ingredients, I could make 1,000 s'mores. With 800 chocolate bars, assuming I have enough of the other ingredients, I could make 800 s'mores. And with 1,000 marshmallows, I can make 500 s'mores, assuming that I have enough of everything else. So can we make 1,000? Can we make 800? Or can we make 500? The most that we are going to make is going to be 500. So after I make those 500 s'mores, I will have some leftover ingredients, but I will be out of marshmallows. So my s'more production would stop. So what is going to be left over and how many of each item will there be? So we know that we are trying to make 500 s'mores and we would need 1,000 marshmallows, 500 chocolate, and 500 graham. So we started with 1,000 graham crackers. So if we use 500, it means we have 500 left. We also started with 800 chocolate bars. We're going to use 500, so that means we're going to have 300 left over. So chemists refer to the reactant, which limits the amount of product that can be made from a given collection of starting ingredients from your original reagents, as the limiting reagent or limiting reactant. So we want to identify the limiting reactant from question 2. That's going to be our marshmallows because they make the least amount of product. Another way of saying that is that we'll run out of marshmallows first. It limits how much s'mores we're able to make. So based on the information that we were given, which of the 3 ingredients weighs the most, weighs the least? So we're talking about an individual item. So what is going to be the heaviest? An individual graham cracker, chocolate bar, or mini marshmallow? So chocolate bars are going to be the heaviest because it says that 1 gross is 36 pounds. So we don't know necessarily how many things are in a gross, but we know that it weighs 36 pounds. We know that a gross of graham crackers only weighs 9 pounds and a gross of marshmallows only weighs 3 pounds. So this means that chocolate bars are the heaviest, even though the gross of chocolate bars and marshmallows are different pounds, different numbers there, it's still the same number of things. So if we have 36 pounds of graham crackers, 36 pounds of chocolate bars, and 36 pounds of marshmallow, which one do we have the most of? So 36 pounds of chocolate bars is only one gross, whereas 36 pounds of marshmallows are 12 gross. So we would have the most of the marshmallows because they are the lightest, and the least of the chocolate bars because they are the heaviest. We want to determine how many gross we have of each of these ingredients. So I'm going to start out with 36 pounds of graham crackers, and we want to convert pounds into gross. So our conversion factor for graham crackers is that 1 gross weighs 9 pounds. So whenever you do 36 divided by 9, we get that we can make 4 gross of graham crackers. We can do a similar calculation for chocolate bars, but this time a gross of chocolate bars weighs 36 pounds. And then finally, 36 pounds of marshmallows weighs 3 pounds. So that would be 12 gross of marshmallows. So if we attempt to make s'mores from the materials that were in the previous question, how many gross of s'mores can we make? So we know that if we have 12 gross of marshmallows, that we could make up to 6 gross of s'mores, assuming we have enough of everything else. 4 gross of graham crackers is going to produce 4 gross of s'mores, assuming there's enough marshmallow and chocolate. And then 1 gross of chocolate bar can only make 1 gross of s'mores. So our limiting reactant in this case is going to be the chocolate bars. And the most s'mores that we can make is 1 gross. So if we're making 1 gross of s'mores, how many of these leftover ingredients are we going to have? So 1 gross of s'mores means that we have 1 gross of chocolate, 1 gross of grahams, and 1 gross of marshmallows. So we started with 12 gross of marshmallows. We're going to use 2. Which means that we have 10 that are left over. We also started with 4 gross of graham crackers, and we're going to use 1, so we have 3 that are left over. So how many pounds of each ingredient of the leftover items will you have? So if we have 3 gross of graham crackers left, we know that 1 gross weighs 9 pounds, so 3 gross would weigh 27 pounds. By similar math, 10 gross of marshmallows weigh 3 pounds each, so that would be 30 pounds total of marshmallows. Now, what about pounds of s'mores? So we know that we can only make 1 gross of s'mores. To do that, I'm going to need 1 gross of chocolate, that's 36 pounds. I'm going to need 2 gross of marshmallows, that's 6 pounds, and 1 gross of graham crackers, which is 9 pounds. So when we total that all together, 36 plus 9 is going to give us 45, plus 6 more gives us 51 pounds of s'mores. So we started with 36 pounds of each ingredient. So 36 plus 36 plus 36 gives us 108 here. So we don't make 108 pounds of s'mores. We only make 51, and then I've got 57 left over. And when you add 57 and 51, you get back to that 108 pounds. So if this is my s'more making operation, somebody's going to get fired because they ordered way too much graham crackers and marshmallows, and now I got to scatter to get more ingredients so that I can keep making s'mores, or these ingredients end up going to waste. So the person who ordered the 36 pounds of each material didn't take into account that the materials have different masses. So why is it not correct to state that if we start with 36 pounds of graham cracker, chocolate, and marshmallows, that we end up with 3 times 36 equals 108. The most s'mores I can make is 1 gross. Then we run out of chocolate bars. So I will have 51 pounds of s'mores and 57 pounds of extra materials that are left over. Finally, we want to write a balanced chemical equation for the formation of a s'more. So I need, according to my recipe, 1 graham cracker, 1 chocolate bar, and then I'm also going to need 2 marshmallows. Now, some people, whenever they write this, they make this 2 a subscript. So we end up with M subscript 2. That doesn't work because marshmallows aren't diatomic. And I know that I need twice as many marshmallow as graham crackers and chocolate, so that 2 needs to be a coefficient. Now, once you make the s'more, notice that here I have the subscript 2 on marshmallow, and that's because we've squished all this together into one compound. So this is sort of like a synthesis or a combination reaction here.